I'm John Ferguson Smart, the author of BDD in Action. So, if you're interested in this topic, feature mapping, requirements discovery, and this sort of thing, there's a whole lot of it in the MEAP version, chapter 6, I think, 5 and 6. Both of those chapters cover feature mapping in some detail. So, if you want to get into the details of it, you can go and look there. So I've been working in software, agile software, for a couple of decades now, and in software development for 3 decades. And over the past decade or so, one thing that I've seen emerge quite spectacularly is a thing called behavior driven development. And what behavior driven development is about is it's a collaboration technique. A lot of people tend to think that it's all about test automation or it's all about using tools like Cucumber, but no, actually it's a collaboration technique. It's and when it's used properly, it's something that I've found really channels teams and forces them to be agile. So one product owner I was working with described it as being what makes you be agile, not just do agile. So does really have some very spectacular results. So what we're going to be talking about today is a technique that we use in behavior driven development called feature mapping. But before we look at feature mapping, we need to understand what behavior driven development is in a little bit more detail. This is a traditional approach to software development where you have the BA and the business who come up with some requirements. The BA will write them up in the form of specifications, and the BA will give, so you might call these specifications user stories. They might go into Jira. Then they get sent to the developers and testers who go away. Developers build something, give it to people, the testers who go away and test it, and then go and deliver it. Now, the problem with this model is that it's pretty much flawed at every step because at every point, you get misinterpretation, misunderstanding, broken communication chains, poor feedback loops, and the errors just cascade all the way to the end so that by the end of the process, the business person is not getting what they asked for in the first place, which is not cool. The problem with this approach is basically that when you silo your efforts like this, what you're doing is you're not actually facilitating the information going from one person to another. You're building barriers. So you're doing the opposite. You're impeding the flow of information. And the result is we get slower feedback, we get misunderstood requirements, we get bugs, and at the end of the day, we get fewer features being delivered, which is not good. So what we try to do and I would say that this even happens with teams that claim to do Scrum. As long as you haven't got a team completely collaborating on your requirements, then you're getting this sort of process. So some other teams are trying to do things a little bit more differently, a little differently. Rather than writing user stories in isolation, what happens is you get your BAs, your product owners who talk to each other, who have conversations with the business, with the developers, with the testers, and try and understand the problem they're trying to solve. And they do this by working through not abstract theories or high level abstract requirements. They talk about concrete cases, concrete examples, business rules, constraints, examples, and counterexamples. And the result of this is that they end up with quite a deep understanding of the problem they're trying to solve. And once they've got this understanding, then the BA and the tester can go away and write up these examples and counterexamples, basically illustrate the requirements with what we call acceptance criteria. But in a behavior-driven development approach, the acceptance criteria are not what you'd traditionally call acceptance criteria. They're what we call executable specifications because they are both executable, they're requirements, but they are also tests. So these specifications written in a format that can be executed, enable you to close the feedback loop automatically. So the specifications become the automated tests. There's no difference or transfer or then what happens is you go and automate these tests, and eventually you'll come up with some software that hopefully reflects what you're trying to build. And how do you know that it reflects what you're trying to build? Well, when you run the test, you're going to produce test reports which mirror the requirements that you agreed on initially. And so this feedback cycle becomes much more accurate. You end up with requirements in an executable format that look very, very much like what the requirements that you agreed on in the first place, but they reflect the software that was built, not what was expected to be built. There's no difference between the requirements on one side and the actual executed results on the other side. So you know that what was built corresponds to what you're expecting. So that's essentially what we try and do in behavior-driven development. In a nutshell, what it is it's a collaborative approach. It's a collaborative technique for understanding requirements and discovering uncertainty. We use rules and examples at multiple levels, and we build a shared understanding by exploring and building up a common language, a common vocabulary, a common way of talking that's very specific to your project. So you get a common language that's project specific, and that's really important. You use automation to provide fast feedback. So automation is not used in the way automation is traditionally done. In BDD, automation is used to drive the process, not to automate manual tests. So it's a very, very different form of automation. And at the end of the day, what we're trying to do is make sure that what we're delivering actually has an impact. That what we're delivering actually matters, that we're delivering the features that are really important. One of the things we find, and this leads to the topic we're going to be looking at today, one of the things we find is that BDD always starts with a conversation. If you're not having this conversation that's happening up here between your developer, your tester, your business person, if you're not having that conversation, you're not doing BDD. Now, back in the day when we used to have this conversation, what we'd do is we'd sit down in a room and we'd go and write these executable specifications. We go and write those given when then statements to directly with the product owner in the room, and we'd come out with a whole lot of given when then statements. And what we found was that writing good given when then statements in a non-trivial domain, so this is a to-do list, it's pretty easy, but when it gets into real world domains, writing those given when thens is quite finicky. It takes a lot of skill to get it right. It takes a lot of time to refine that, and you end up doing a lot of back and forth to get that right. But this is not a good use of a product owner or a product owner's time. What will happen is if a product owner is focusing on writing out given when thens, they'll lose track of what actually matters, which is the examples and the business rules. So what we really want is not to use given when then statements in this, what we call the three amigos, in this conversation, because it distracts them, because it means that they focus too much on should it be a when or and then, and not enough on did I remember all the edge cases and all the acceptance criteria, all the business rules that are important, all the outcomes that we're looking for. So over the years, trying to do BDD this way, we found that we needed a different approach. Another problem we found was that this format, this given when then notation, lends itself to abuse. It lends itself to very bad test scripts like this one. You see a lot of this sort of formatted given when then. Basically, 90% of cucumber scenarios are rubbish out in the wild. There's a proliferation of BDD tool being used incorrectly, and it creates a huge problem in the industry, because it creates test scripts that become unmaintainable, very unwieldy, and that don't do the job they're supposed to do. Hard to write, they take a long time to write, they take a long time to fix, they're fragile. And the core reason that this happens is it is hard to write good given when then statements. It takes some skill. You need a bit of practice. You need to know what you're trying to achieve. And when you come at these given when then statements from the point of view of writing test scripts, then you end up with test scripts like the one you can see on the screen, which is not good. So we wanted to figure out a way to get away from that, to help people, guide people towards a cleaner, more business-focused way of writing these given when then statements, the way that they're intended to be used. And so what we found was that rather than writing your given when then statements either before you have this Three Amigos session or during the Three Amigos session, the best way to do it is to do it after Three Amigos session, to do it in a separate session. So the Three Amigos session is where you discuss business rules, you discuss examples, you discuss edge cases and constraints, outcomes that you're trying to achieve, but you don't try and go into the syntax of this given when then. You leave that for a separate session for people who are more familiar with the format, so BAs and testers who can work through that and come up with a well-written, cleanly written, but actionable set of acceptance criteria that you can then show to your business people and to ratify with the business folk. And that's where feature mapping comes in. Feature mapping is a technique, a collaborative technique, which allows you to get people into a room and have a focused, framed conversation about a set of requirements to explore flows and edge cases and variations and combinations, to see what you know, to see what you don't know, to see what areas you need to explore further, and at the end of the day to come up with something that is not gherkin scenarios, because again that takes too long to write, but is in a format that is very easy to then transcribe into good quality given when then statement. Rather than explaining what it is, what I want to do is walk you through a concrete example of how feature mapping actually works. So what we're going to look at is an application called Coffees R Us, which is a mobile app, which allows you to order coffee at a chain of coffee stores. So what I'm going to do is pick up a random story from this application, and we're going to walk through it using feature mapping. We're going to see what comes out of it. So our user story looks like this. Refund cancelled orders. So as a coffee lover whose plans have changed at the last minute, I want to be able to cancel my order so that I don't pay for coffee that I don't drink. So we start off with a user story that we get for a feature. User story can actually be bigger than a user story. Now, what comes into the sprint at this level, we don't actually know the size of it, because this sort of discussion, the Three Amigos, happens before sprint planning. You don't have a clear picture of how big a requirement is until you've talked about it and broken it down into examples and acceptance criteria. Then you can say, okay, this is actually 3 stories in the whatever size we deal with. It's not 1 story, it's 4 stories or whatever. But you don't do that beforehand, you do it afterwards. So that's why I say this is a user story, but it may be a big user story. So I'm going to call it a feature. So this feature, refund cancelled orders, the way it's phrased is a fairly standard Agile way. But to really get a grip on it, to really understand the subtleties, I find it really useful to write a detailed illustration of that story. So basically, walk me through this, tell me how it works in the real world. And this doesn't have to be done in the feature mapping workshop. It can be done beforehand, because it's basically the product owner or the BA relating how this story works in the real world. So here we've got Sarah who leaves her apartment. She orders her morning latte. She's 30 minutes away from Barry's coffee shop. 5 minutes later, she realizes that she needs to go to a different office. So she won't be going near Barry's coffee shop. So she cancels the order. So she's 30 minutes away or 25 minutes away and she cancels the order. She pays by credit card and the refund gets refunded directly onto her credit card. So you can see when we work through a detailed example, what happens is we get a few more nuggets of information that will come in handy afterwards. And it's because we have this concrete example, it gives us things to talk about. It gives us things to question. So we say, well, 30 minutes and 5 minutes later, so that's 25 minutes. Is that significant? She paid by credit card and she gets refunded. Are there other ways she could get paid and get refunded and so forth? So once we have our story, what we do is we identify key business rules. So one of the business rules that came out of that illustration was the idea that an order cancelled less than 5 minutes, well, actually it wasn't, but it's something that from a conversation could emerge that less than, if it's cancelled more than 5 minutes, she'll get a refund. If it's less than 5 minutes, there will be a fee. With feature mapping, what we do is we put cards, index cards with different colors on a board or on a table or on a visual representation on PowerPoint or Skype or whatever. And we use them, lay them out to illustrate the different flows through the application. We start by putting the blue cards, which represent rules, on the left-hand side. And then each card, each rule card, each business rule needs at least one example. Examples we represent with green cards. So examples, if you've done example mapping, there's a lot of similarity with feature mapping and example mapping in the notation because it's kind of deliberate. It's the same communities that do both techniques. The example we might have is the one where Sarah has to cancel her order with time to spare. So that means she won't get a penalty fee. So far, we have a rule and we have an example. Then, once we look at our example, we say, well, walk me through this example, break it down for me, tell me what happens at each stage. Tell me the steps that the user will go through to achieve this, to finish this scenario, this flow. And steps, we represent them in yellow. So our first step might be, well, Sarah orders her coffee 30 minutes away from the shop, and Sarah cancels 20 minutes away from the shop. So we have these sequences of steps. Each example, we break it down into steps. And you can have as many steps as you want. Usually you don't have a huge number. What this does is it encourages you to think about the meaningful steps and to group things together and not worry about the details. So if Sarah had to enter her address, register and enter her address, we would not need a step to say Sarah enters her first name, Sarah enters her last name, Sarah enters her date of birth, because that was probably not going to be relevant at this level of the flow. All we'd say was Sarah registers, Sarah enters her contact details. So this allows us to aggregate information together into the meaningful steps. Now, the steps by themselves aren't usually enough to make a meaningful flow, a meaningful scenario, because what happens is we have a sequence of steps. Sarah orders a coffee, she cancels her order 25 minutes. So what? What's the outcome? What's the result that we're looking for? So we need something to describe these outcomes, and we call those outcomes consequences. We represent them with a different color. Historically, the different color is whatever color is left over in the post-it deck. So sometimes we have mauve, sometimes we have orange. Doesn't matter too much. The conventions are usually orange or purple, but they are fairly loose conventions. We want them to be different from the steps to distinguish them. Now, what's the consequence here? Well, a consequence of Sarah cancelling 25 minutes away means that Sarah gets fully refunded. So that's the outcome. Now, one thing that consequences allow us to do is have conversations about whether there are other outcomes that we need to consider. Is Sarah's fully refunded? Is that all we need to consider? Well, no. We also need to remove the order from Barry's order list. If we don't do that, it would be a bug. So we need to consider all of the outcomes of a particular scenario. And that's why consequences are really powerful. They really make us think about those different flows and different variations that can happen in a particular scenario. Then what we do is we look for variations. So feature mapping is all about looking for variations. And one of the really nice things that people say about feature mapping, doing it, is that using the steps allows you to look at each step and say, well, what else could happen here? What other outcomes could happen? What variations could there be? What else could go wrong? So in this case, we might say, well, Sarah cancels her order 25 minutes. What else could happen that would produce, okay, we could say Sarah cancels her order 20 minutes away from the shop and Sarah gets fully refunded. But then we might say, well, that's a pretty boring outcome. That's exactly the same as the first one. We don't need to worry about it. But what if it's 2 minutes? If Sarah cancels the order 2 minutes from the shop, in that case, we have a different outcome. She's not fully refunded. She's charged $1. And so we add another example. You can see we've got these lines going here to indicate that we're basically doing the same thing as the previous. So Sarah orders a coffee, we don't duplicate it, we just skim over it. And they both go to Barry, the order being removed from Barry's list. But the meaningful difference is that, well, this example has got a different title, the one where Sarah has to cancel the order at the last minute, and a different step 2 minutes away, and a different consequence. So feature mapping is all about finding variations and consequences. And it's also about identifying uncertainty. So one thing we do when we spot uncertainty, when we spot something we don't know, we mark it so that we can highlight its existence, so we can make sure people are aware of it. So we might have a question, how does a fee work if the customer pays with loyalty points? So Sarah gets charged $1. What if she paid with her bonus points, her loyalty points, as opposed to with cash? How would that work? So we don't know the answer to that question. So we put a pink card to say this is a question. And then we basically repeat this process for different rules and different examples. And we end up with a wall full of different rules and examples. Sometimes I haven't shown it here, but we can group the rules into groups of rules and have what we call guidelines, so that we can categorize make a hierarchy of rules. Basically, what happens is you can map out the flows or the scenarios for a particular requirement at different levels, at the level that makes sense for you, and end up with a high level view and then quite a detailed view, but of the variations that you need to consider. And you also have concrete examples for each of these variations. So, for example, here we have these concrete examples. They're not vague things like she gets charged a fee. We have real data here. So we've got another rule that talks about premium members being charged 50 cents. So here we've got another rule here, but you'll notice here we only need to talk about the case where she gets charged. We don't need to worry about when she gets fully refunded, because that logic would be the same. There might be cases where that would be a bit different and we'd need another flow. So we decide what flows are significant and what flows we want to include in the feature map. And these scenarios end up being our guidelines for our acceptance criteria. So these flows, each flow will result in an automated acceptance criteria. And so when I say feature mapping, that does two things. It's very intuitive. It's very easy to teach people how to do this. People pick it up business owners pick it up very quickly. So it's quite easy to show people how to do this and to have really productive conversations. But when we're doing this, we end up with a format that maps very closely to quite reasonable given when then statements. Now, there are some more advanced tricks that we won't be looking at here uh, because it'll take a bit longer, but we can convert feature maps into tables and have more structured formats. But as a rule, what happens is if we can express a requirement as a feature map, we get the right level of granularity, the right level of abstraction for our given when then statement. So it makes it much easier to write good quality given when then. And when teams use feature mapping, what happens is that there's a whole lot of errors or a whole lot of mistakes that go into making bad gherkin, bad given when then statements. They just don't happen with the feature map. They just don't happen because, for example, a common error is that people include lots of clicks and selects and UI details. If you started talking about clicking and selecting and entering values here, this would get way too big. It would be very obvious that you were looking at too granular a detail, too granular a level to have meaningful conversations. To have meaningful conversations, you get to understand what level of abstraction you want to talk about. And that is the level that works well at the given when then level. So that in a nutshell is feature mapping. If you want to know a little bit more about feature mapping, I've put up a little website here. It may not be live yet. It will be live within the coming hours basically it has a whole lot of resources on feature mapping, and it has a mailing list that you can sign up to because there's going to be an ebook and some training workshops and some resource free templates and other sort of useful helpers, cheat sheets, to help you get started with feature mapping, help you apply feature mapping in your own organizations. Probably not straight away, but at some point, give that a go. Go on to featuremapping.com and you can sign up and get information about when all of that will be available.